Okay, so let me just tell you the meaning of antiderivative and how to start with the integration. So in order to tell you the antiderivative, just suppose there is a function capital X and whose derivative is going to be fx. Assume the situation. Also, if I can ask you, if I differentiate capital Fx plus c, what will be the right hand side?
If you differentiate it?
See, this is the information I have given to you. Derivative of a function capital Fx is small fx. In case of capital Fx, if I differentiate Fx plus c, c is a constant, what should be the outcome?
Doesn't the c disappear?
Yes, c will disappear. So you will be getting Fx only. Okay, let me just elaborate more. So because the derivative rule is linear, so I will be differentiating Fx plus and I will be differentiating c. Any doubt? C. You need to differentiate, and when you are differentiating, there are two functions, Fx and c. What?
C becomes
The derivative of c becomes 0 because the derivative constant is 0. Am I right?
Yeah.
So, but the derivative of capital Fx, I told you it is small fx. This is the information I have given you. And the derivative constant is 0. So ultimately, you will be getting fx only. Yes or no?
Yeah.
Perfectly okay. So this is going to be the basic for you. So I'm going to use this fact. Now, let us come to the term antiderivative. So as you know, we know about derivatives. Antiderivative basically that is the inverse process or the reverse process of differentiation. What it says that if derivative of a function capital Fx is small fx, in that case, if I do the inverse term, that means fx, if I do the inverse is going to be integration. So this is going to be the inverse or the reverse part. So whenever you do the integration of fx, you will be getting fx. This is what is known as antiderivative. And because I have seen either if you differentiate fx or fx plus c, you will be getting the same outcome. So we usually add c there, c based on this assumption, where this c is called constant of integration. So if you know that there is a function whose derivative is something, so the integration of that term is going to be capital Fx plus c. Let me just try to elaborate more. Can you please tell me what is going to be the derivative of x?
Derivative of
X, yes.
Just 1.
Perfectly okay. It is going to be 1. You are absolutely right there. So now do the reverse part. What is going to be the integration of 1?
Dx.
It is going to be x only.
Yeah, x, sorry, yeah.
And yes, and you need to add the constant of integration c.
Yeah.
See, there are two parts of integration we will be learning. One is indefinite integration, one is definite integration. So right now we were focusing on indefinite integration, and in indefinite integration, you must add the constant of integration c. Okay.
Yeah.
So unless I'll tell you about the definite integration. Now let us just do some more facts. Just suppose tell me what is the derivative of x square? Is it 2x? Right?
The integration or the definite?
Derivative of x square.
Yeah, 2x.
2x, perfectly okay. So if I ask you with a little bit modification, what is x square by 2? What should be your answer? Is it x only?
It will be 2x over 2, which is just...
It is going to simply x for you. Am I right?
Yeah.
So that means to say that now the antiderivative will play a role. What is the integration of x? You will tell me it is x square by 2 plus c. Do you agree?
Yeah.
So we need to generalize this fact. I'm asking you because I can tell you the same for x cube, for x power 4. So, but we need to restrict ourselves with the general formula. Let me ask you, what is the derivative of x power n plus 1? Is it n plus 1 x power n? What is n? N is not equals to minus 1 intentionally. Okay, I'll tell you why I'm not using the wording n equal to minus 1, not equal to minus 1. Is it the derivative x power n plus 1? This is how the power rule goes.
Yeah.
If you allow me, I wish to divide both sides by n plus 1. See, in integration and differentiation, you can differentiate with a constant. So you can divide and multiply with a constant on both sides without any issue. Okay, constant hardly matter, hardly change anything in the differentiation and integration. So that means to say that if I ask you what is the derivative of x power n plus 1 divided by n plus 1, your answer will be x power n. And now I use the antiderivative term. What is going to be the integration of x power n? The answer should be x power n plus 1 divided by n plus 1. Is it okay?
Yeah.
And
Okay.
I'm going to add a constant of integration. This is going to be our general formula, but there is a catch. The catch is I told you n is not equals to minus 1. Why I have taken this specific condition? Because in case if n is going to be minus 1, then the denominator is going to be 0, and which I do not want. Otherwise, my terms are going to be inconsistent. Am I right? The denominator is 0, numerator is not 0, so it is not going to be a mathematically valid term. So therefore, whenever you apply this type of formula, always remember this n cannot be equal to minus 1. That
Yeah.
means to say that there must be some specific formula for n equals to minus 1 also, right? Let us just try to find that. So in order to find that, let me remind you, there was a function log natural x, ln x. What was the derivative of ln x? If you can tell me.
Ln of x.
Yes. Is it 1 over x?
I was gonna say 1 over x.
Perfectly okay. So if it is 1 over x, that means using the antiderivative, the integration of 1 over x dx is going to be how much? Ln x
Plus c.
plus c. There is small modification there. See, I have not restricted x to be negative or positive. As you know, ln x is defined only for the positive real numbers. So intentionally, you have to use absolute values here. This is the only change you need to focus, because in case, just suppose for some particular values, you have got ln minus 2. It is not defined. So I should not get terms where this log is not defined. So intentionally, you will have to put the mode. This is the only modification you need to learn. Okay. So if you can see, this expression is basically covering the condition where n is going to be minus 1. See, I can rewrite the same expression x exponent minus 1 dx, which is corresponding n equals minus 1. The answer is going to be ln mod x plus c. So now you have completed two important formulas. Whenever I ask you what is the integration of x power n, you will tell me it is x power n plus 1 divided by n plus 1. And whenever it is x power minus 1 or 1 over x, you will tell me it is ln mod x here. Do you agree?
Yeah, I agree.
Perfectly okay. So let me just discuss with you a question based on the same. You please try to help me. And let me tell you, differentiation and integrations, they follow the linear property. Linear property, this stands for they are going to be separated with the positive and negative sign. Okay, so this is the question I have taken from a book. I can share the book maybe later on after the class if you wish. So look at the question there. In the question, this integration sign stands for antiderivatives, and there are 4 terms given to you. Linearity property says you can separate them with the positive negative sign. So the first term I'm going to separate. The second term is going to be, this is going to be cube root of x square. The
This
third
can
term,
be converted to 3/2, right?
yes, I will do that in the next step. Thank you for that. I'll do in the next step. It is going to be x square dx. So in the first step, I have separated the integration part, square root of, so cube root of x, and this is integration. I forget to mention, yes. So let us just try to write down in the format we wish to have. X power 4 dx, because the integration formula you know is x power n dx is going to be x power n plus 1 divided by n plus 1 plus c. This is the formula actually you know. Am I right? So I need to convert every integral in the format, in this format, sorry. So the next is going to be x as you told me, and I'm thankful for that. It is x power 2 by 3, right? The
Yeah.
next you should write, see, you can take the constant always out. Whenever there is a constant term, you can always take this constant out before the sign of integration. And I can rewrite the expression like x power minus 2 dx. Do you agree?
Yeah.
And what is going to be the next term? This is going to be negative 1 over 3, because 1 over 3 is a constant. And you need to write the expression x power. It is cube root of x, that is x power 1 by 3. But I wish to have in the numerator, so this is what I will do. Any confusion there?
Yeah, my algebra is bad. I know it's because it's 1 over something, but why do you put the negative on that?
Okay, I'm telling you that. See, the expression was 1 over, it was cube root of x. So it is going to be x power 1 by 3. Am I right in the denominator?
Yeah.
I have an expression which is in the numerator only. There is nothing in the denominator.
Oh,
So
okay.
I wish to convert them. So what I will do, I will just transform this into numerator, and for that I'm just using the negative sign. Right?
Yeah.
So now it's a simple task for you. Start with the first one. You need to just check what is the value of n and apply the formula. So for the first integral, the value of n is 4. So I should be having x exponent 4 plus 1 divided by 4 plus 1. This is the answer for the first integral. Second integral, x exponent 2 by 3 plus 1. Add n plus and add plus 1 in the numerator and divide by the same. Am I right?
Yeah.
Okay. Yes. Next is going to be negative 2. X exponent, what should I do? Negative 2 plus 1 divide by negative 2 plus 1. Right?
Yeah.
What should be the last one? What should be the last expression?
X to the power by
X exponent negative 3 plus 1.
plus 1. Yeah.
And I should divide by the same.
By the same.
And yes, you need to add the constant of integration because we are using antiderivative and basically indefinite integration. Right? So now our task is to simplify only. So if you simply try to simplify, the first term is going to be x exponent 5 divided by 5. Second term is going to be x exponent, how much it should be? 2 by 3 plus 1?
X powered by 5 over
5 over 3.
3.
Perfectly okay. And the next term is going to be, keeping 2 aside, it is x power minus 1 divided by minus 1. We will adjust the negative sign maybe in the next step. Next is negative 1 by 3. It is going to be x exponent minus 1 by 3 plus 1 is how much?
Negative 2 over 3.
Negative 2 over 3.
over
No, not
negative.
negative. Is it positive? It is positive 2 over 3 maybe.
Oh, yes, yeah, other two maybe.
And plus c. Now our task is almost done. We need to just write in a better format. The second term c, whenever you have p over q in the denominator, so it is going to be q over p always. That means whenever you divide by something, it is equivalent to multiply by the reciprocal. So you're dividing by 5 by 3. I'm going to multiply by the reciprocal. This will write in a better format. Any doubt?
Yeah.
Next, negative negative will make it positive. It is 2 over x there. X power minus 1. See, x exponent minus 1. It is equivalent to 1 over x. Most of the time, whenever I try to finish the value, finish the answer, I wish if I can have positive exponents of most of the terms. In case if I have no, I need not to match the final answer. So this is the final format I wish to have. Always the exponent should be positive. Okay, the last one is going to be negative 1 by 3. It is already there. Now you need to multiply by the reciprocal of 2 by 3. That is 3 by 2. X exponent 2 by 3. Add the constant of integration c. Yes, you can further simplify. 3 cancel out with this 3. So whatever left is your final answer. Is it difficult?
No.
No, perfectly okay. It is not difficult. So can you just help me with one more question? Then after we will start with the next set of formulas for the antiderivative. So next task is for you. And you can dictate me if you wish, or if you wish to write down somewhere and try to send me, that is also possible. So you want to dictate me? How should I proceed?
Yeah.
Please.
So you separate every one of them.
Perfectly
so
okay.
Integral 3x plus integral 4x.
You see the negative, positive, negative sign.
Yeah, negative plus.
And positive, it is 2x cubed dx.
And then
Perfectly
after
okay.
that, derivative of 3 dx is just 3x.
Perfectly. Just before this, whenever there is a constant term, you need to take that constant out of the sign of integration. It is 3 integration 1 dx. Negative, because there is a constant term 4, you can take the constant out. You need to write down like this. And again, you are taking the constant out. You are writing like this. Any doubt? Now,
No.
if not an issue, so keep the constant as it is. Now, how the antiderivative works? Whose derivative is 1? The answer is x. This is what we discussed. Am I right?
Yeah.
This is how the antiderivative works. I need not to learn all the formulas. The question should be whose derivative is this? Obviously, we have an explicit formula for x power 1. And what was the formula? The integration is going to be 1 plus 1 divided by 2. Perfectly okay. And what should be the integration of the last term?
2 x. Yeah.
Exponent 4 divided by
4.
By the same 4. Okay. Just a simplification and you are done with it. 3x negative 2x square. And how much it should be? Positive 1 by 2 x exponent 4 plus c, and we are done with it.
Yeah.
Was it a difficult formula?
No.
Perfectly okay. We will be having variants of the same question maybe later on. But here this was the first task. Second, after this, let us just try to discuss some exponential functions. And using the same technique, that is the antiderivative. Try to help me. What is the derivative of e exponent x? What is the derivative of e exponent x? It is the same basically. Ex is such a nice function whose derivative is going to be the same. And if the derivative is same, the integration is always going to be the same, except the c part. Because integration is the reverse process of differentiation. So it is going to be e power x basically, But yes, you need to add the constant of integration. Do you agree? So like I told you, e power x is such a nice function whose derivative is e power x itself. So the integration will follow the same. There is one more function which is going to be exponential, and you know the derivative maybe. What is the derivative if there is a constant a exponent x? What is going to be its derivative?
A to the power by x.
A exponent x, but yes, you need to multiply it by ln a. Okay, you need to multiply by ln a there. This ln a, ln is log, a is a constant, this is a constant term. What we usually do with the constant term, let me just try to divide both sides by the constant term. Let me divide by both sides by the constant term. So now it is in the perfect format from where I can get the formula for a exponent x. So the integration of a exponent x should be this term. What should I write here?
Ln a multiplied by ln a. So
It is going to be ax upon ln a, right?
Oh, okay.
The integration part, the reverse part basically, and you need to add the constant for integration. That is all.
Okay.
So there are two formulas for the exponential terms. You got it? There are two formulas based on the exponential terms. So let us just quickly try to revise and try to have a question based on the same. So I have a question for you, like it is 2e power x plus 3 divided by cube root of x plus a power, let me just use a specific wording for a, it is 3 power x. This is a question for you. You need to integrate. You need to help me in integration. Please help me. How should I proceed?
You distribute the integral.
Perfectly okay. Which is 2e exponent x.
Yeah.
Then after it is 3 divided by x exponent 1 by 3. I will take this x term maybe in the next step in the numerator. And the last term is going to be integration of 3 power x. Can you please tell me 3 power x, what type of function it is? Is it polynomial or exponential? What type of function it is? See, whenever you have constant term and exponent is a variable, the answer should be exponential term. So it is going to be exponential function. So both the rules, these two rules are going to be applied to e to the power x, because e is also a constant, as you know, and 3 to the power x. Clear?
Yeah.
Now please try to help me, and the integration is already there for you. What should be the first step now? Taking 2 outside, you will be having e to the power x. Keeping the constant out, you need to adjust the exponent. It should be x exponent negative 1 by 3. Right?
Yeah.
And the last term is going to be, I cannot take this 3 out. You need to write it as it is.
3.
So now what is the final part?
3 to the power of x, don't you add? Oh, you don't add it by 1, it just stays the same.
No, it is not. It is an exponential term. I cannot add 1, and I have not integrated it yet.
Okay.
So keeping 2 as it is, help me. What is the integration of e power x? I may have told you.
E power x.
It is as it is. Perfectly okay. 3. I will be using the x exponent negative 1 by 3. This is the polynomial rule I told you. But it should be x exponent negative 1 by 3.
2 over 3.
Yes, 2 over 3 divided by 2 over 3. Perfectly okay. And what is the last part? 3 power x. What should be the integration there? It is
not sure.
3 exponent. Use this rule. See, a is 3 for you here. That is why I told you. A is 3 for you.
Okay, so a 3 over x over ln.
Over ln 3. Okay, log natural 3 plus constant of integration. Now just write down in a final format and you're done with it. It is 2 exponent x plus 3, whatever in the denominator, multiply by the reciprocal of that, that is 3 by 2. Exponent how much? It should be 2 by 3. What it should be? It is 3 power x upon ln 3. I will keep it as it is only. And plus c, this is what your integration is. Okay, yes, if there are something you can simplify, like you can simplify this term. It is a minor term, maybe you can do it without any issue. Any doubt there?
3 multiplied by.
Any doubt?
You simplify it to 3 over 2.
How I simplified?
Oh wait, no, you just added it. But isn't it? Wait, isn't it x to the power by 3 over 2?
You need to
Hey,
simplify this
oh,
term. What it should be? It is going to be 9 by 2 there. Isn't it?
yeah, 2 over 3 divided by 2 over 3.
So 3 3s are 9. See, when you multiply
Oh,
3 by 2, if there is nothing in the denominator, by default it is in the numerator. So you need to multiply in the numerator only. So 3 3s are 9. Numerator is going to be the same. Am I right?
but isn't that an exponent? 3 over 2.
Keep it as it is. It has nothing to do with this with the multiplication of constant. This term has nothing to do with the multiplication of constant. It will keep it as, you have to keep it as it is only.
Oh, where did you get 3 over 2? That's my question.
Okay, there was a term x exponent negative 1 by 3 and plus 1. If you can see, this is a term given to you. Let me just highlight that. And when you simplify the exponent, it is negative 1 by 3 plus 1 is going to be 2 by 3 for you. And that is the same term you divided.
Yeah, that I understand that.
Perfectly okay. And the rest of the terms are going to be the same. It is 3
So that
exponent.
part I understand. It's just I don't understand how that 3 over 2 can become a constant.
Now the doubt is clear, or should I explain it more? Little bit.
Yeah, just explain it more.
Perfectly okay. So in this part, basically, let us just discuss only one part, which is creating the issue, like 3x exponent negative 1 by 3 and dx. Okay, you know 3. What is a variable term which contains x? Like e to the power x, it is a variable term. Ln x, it is a variable term. Sine x, wherever you find an unknown like this, these are going to be variable terms. So 3 is a constant for you. Now how to integrate? The integration formula we learned, it is going to be x exponent negative 1 by 3 plus 1 divided by negative 1 by 3 plus 1. So if you tell me the numerator part, it is a variable term because it contains x, but the denominator part, it is a constant for you. Am I right?
Yeah.
So keeping 3 as it is, simplify the terms. X power 2 by 3 will be in the numerator. Yes or no?
Yeah.
And the same 2 by 3 will be in the denominator. Now, how we simplify the denominator? Whenever something is in the denominator, we multiply by the reciprocal of that to simplify. So 3 is already there. What is the reciprocal of 2 by 3? It is 3 by 2.
Oh, okay.
And keeping the exponent same.
That makes sense.
Okay, and like I told you, 3 multiplied 3 by 2, it is 9 by 2 there. If nothing is in the denominator written, by default it is in the numerator. Okay, so x exponent 2 by 3 and you got the answer. Any doubt there?
No.
Perfectly okay. So we have covered the exponential functions, so and the polynomials. Now the next task to learn the antiderivative is going to be the trigonometric function. Okay, so let us just try to do that. Let us just try to do that. So trigonometric functions. You please try to help me. What is the derivative of sine x?
Cosine x.
Cosine, perfectly okay. It is cos x.
Cosine x.
Perfectly okay, cosine x. Cosine x we write like cos x. Okay. What the antiderivative formula will tell you? What is going to be the integration of cos x?
Sine x.
Perfectly okay. It is sine x plus at the constant of integration, that is c. What is a difficult task?
No.
No, perfectly okay. Now the next question. What is the derivative of cos x? Like the cosine x, you know.
Negative sine x.
Negative sine x. Perfectly okay. So I need to use this negative sign. I need to remove the negative sign from the right hand side. Can I say that negative of cosine x? Sorry, I should not use this notation. That is a mistake from my side. It is derivative basically. Sorry. Okay. Now the question is, what is the derivative of negative cos x? Should it be sin x only?
Yeah.
So now, as you know, it is in the perfect format for me. If I ask you, what is going to be the integration of sin x? What should be your answer?
Cos x.
It is going to be negative of
Cos
cosine x, what you know, and plus at the constant of integration. Is it okay? Now, do I have, I know the next question, sorry. After sine cos, we know about tan and cotangent. Let us just talk about that. What is the derivative of tan x?
secant square x.
Perfectly okay. So what is going to the integration of secant square x?
Tan x.
Perfectly okay. So basically you need not to learn all the formulas. If you know the derivatives, you can just ask the question, whose derivative is this? So whose derivative secant square? Tan x is the answer. Whose derivative is sin x? Cos x is the answer. This is how we should learn the formulas. Okay.
Yeah.
Okay, perfectly okay. So let us do the next. Whose derivative is cotangent x? So what is the derivative basically? What is the derivative of cotangent x?
Negative cosecant square.
Cosecant is perfectly okay. So it is writing like CSC. The notation is CSC for cotangent x. Square is there. You need to adjust the negative sign. So I wish to adjust the negative sign here. So let me, if it is negative, it is going to be positive, like I have done before. So now, what is the integration of cosecant square x? What it should be?
Negative cotangent.
Negative cotangent x. Perfectly okay.
Yeah.
Let's see. So basically, we have got four formulas here. One for cos. Okay. One for sine. Next for secant square, as you can see. And next for cosecant square. These are four formulas you have learned here. There are two more formulas. These are the basic formulas. Yes, there is maybe a question, what is the integration of tan x? We have not learned, or cotangent x. We will learn them maybe in the next classes, where we will first learn the substitution technique, and then after we will derive the formulas for some of the trigonometric expressions. Okay. So the question, what is going to be the integration of tan x? I can tell you, but it is going to be maybe discussed in a better manner, maybe in the coming classes. So we have to wait for that. Next, we know that we discussed the derivative tan and cotangent x. Help me, what is the derivative of secant x? What is the derivative of secant x? Should I help you?
Alex, I'm not sure. I forgot.
It is going to be secant x.
Oh yeah.
Tangent x.
Oh yeah.
So antiderivative says the integration of secant x tan x dx is going to be how much? It is secant x only. So we have got some expressions for some, we have got integration for some specific expressions.
Yeah.
Now, in the end, please help me. What is going to be the derivative of cosec x?
Cosecant x, cotangent x.
Yes, it is negative of cosecant x
Oh,
and
yeah, negative, sorry.
cotangent of x. You are perfectly right there. So you need to adjust the negative sign maybe on the left hand side. So if you allow, I'll adjust them. What is the integration of cosecant x into cotangent x? The answer is going to be, it is going to be negative of cosec x plus c. Any doubt there? Any doubt there?
No.
Perfectly okay. So these are going to be your integration of some of the trigonometric terms. Give me a second. Let me just find a good question for the same. Give me a second, please. Not right now. Okay. I need to just create a question. Please try to help me. What is going to be the integration of this sine x plus secant x tangent x? Please try to help me. What is the integration of sine x plus secant x tangent x? So first of all, like from plus minus, integration is going to be separated. As you know, it is sine x dx plus integration of secant x tangent x, right?
Yeah.
Perfectly okay. Try to help me. Whose derivative is sine x?
Derivative of sin x is negative cos x.
Negative cos x. This is the integration you know. Whose derivative is secant x into tangent x?
Negative.
Not negative.
Negative secant. Negative secant.
Positive secant x. See?
Positive secant. Yeah, sorry. Positive secant.
Perfectly okay. And you got the answer. Was it a difficult task?
No, no.
Perfectly okay. Another question based on the same. For that, I'm pasting a question for you. Yes. This is going to be a question based on the technique we have learned till now. It is secant square x divided by cosecant square x. Again, we do not know what is going to be the answer exactly, but yes, we can simplify them. Secant square is going to be 1 over cos square x. Am I right?
Yeah.
What in the denominator? Cosec square x. The notation may be different. You will write the cosec only CSC. What is cosec x? It is going to be the reciprocal of sine x. So it is 1 over sine square x. Any doubt?
Yeah.
So the first term, it is the numerator part. This is the denominator part. How should we simplify? Keep the numerator as it is. Multiply by the reciprocal of denominator. This is how generally we simplify them. Keeping the numerator as it is, multiply by the reciprocal of denominator. Try to help me. Numerator is 1 over cos square x. Multiply by the reciprocal of denominator. What it should be? Sine square x divided by 1. Do you agree? Check that denominator 1 over sine square x. You need to multiply by the reciprocal of it. Am I right?
Yeah.
Perfectly okay. So what it will be? It is going to be sine square x divided by cos square x, which we know it is going to be sine over cos is going to be tangent x, right? And because square is there, I should be able to write tan square x here. So what the information we used, we know that my sine x divided by cos x is tangent x.
That's a trig rule, right?
Yes, it is a trigonometry. So we are at the point where we need to integrate tan square x, but again, I do not know what is the integration of tan square x. There is no formula tells me what is the integration of tan square x. So I need to use a technique. See, integration is all about techniques. There are lots of technique will be there. So the technique is, you know that 1 plus tangent square x is secant square x. It is an identity. You remember the identity? It is a famous trigonometric identity. 1 plus tan square x is secant square x. I know the integration of 1. I know the integration of secant square x. So if I can represent tan square in terms of both of these two, I can integrate them. So what should I do? I should replace tan square by secant square x minus 1. Yes?
Yeah.
So you should help me. It is secant square x.
It'll become
Secant square x is going to be
tangent x plus
integration 1 is going to be
x.
x. You need to add the constant of integration c. So this is how you should be able to do some questions.
Yeah.
Right? So based on that, let me just paste some question for you. These are going to be some standard question. You should be able to try those questions if not an issue. You may consider them as a homework for the class. Okay, so whatever the techniques we have learned, so these questions are based on the same, nothing else. So these are going to be homework for you.